Okay, this is Math 21C, Quiz 1. The first question asks, do the following sequences converge or diverge? You must justify your answer. If the sequence converges, find the limit. The first sequence we're going to look at is a sub n is equal to 2 minus cosine of n over n plus 3. One thing we should notice here is that the top has 2 minus cosine of n. Cosine of n is a very nice function because it's bounded above by 1 and below by negative 1. So in fact, we know that 2 minus cosine of n is going to be bigger than, so the most this can be is 1. So the least that 2 minus cosine of n can be is 2 minus 1 or 1. And then 2 minus cosine of n can at least be negative 1. So at most cosine of n can at most be negative 1. So at most 2 minus cosine of n can be 3. Now on bottom we keep this n plus 3. So we end up with this sequence a sub n bounded above by 3 over n plus 3 and below by 1 over n plus 3. Now notice 1 over n plus 3 as n goes to infinity goes to 0. 3 over n plus 3 as n goes to infinity goes to 0. So that tells us by the sandwich theorem that 2 minus cosine of n over n plus 3 also goes to 0. Okay, so the sequence converges, and this is our limit. Okay, the second sequence we're looking at is a sub n equals negative 1 to the negative n. I'm just going to rewrite that as 1 over negative 1 to the n. Now notice negative 1 to the n, all that's doing is oscillating back and forth between negative 1 and 1. So for when n is odd numbers, this bottom is going to be negative 1. When n is even numbers, we're going to have 1 on the bottom. So this whole thing is just oscillating between 1 and negative 1. So if we draw a little picture of it, at first we're at negative 1, and then we're at 1, and then negative 1, 1, and so on and so forth, right? So clearly this is not converging to anything. If we look at it, all we're doing every time is oscillating back and forth between the same numbers. So this sequence diverges. Okay, now problem number 2 asks, do the following series converge or diverge? You must justify your answer. If the series converges, find the limit. Now notice I emphasized series. Some people looked at this and told me a lot about the sequence, but what we're asking about is the series. Okay, so problem A asks for, describes the series, the sum as n goes from 1 to infinity, of 1 plus 1 over n all to the n. There's actually quite a few ways to do this. I think the simplest way is just to notice that this is bigger than n equals 1 to infinity, the sum of 1 to the n, right? Because each of these, for any n, 1 plus 1 over n is bigger than 1, right? So that to the n is definitely going to be bigger than 1 to the n. Well, 1 to the n, this summation is just the summation from 1 to infinity of 1. Well, that clearly diverges, right? So this whole thing, because we bounded below by a series that diverges, we know that our series diverges. Okay. Now, one other way that I saw is let's look at the limit of the actual sequence of the terms in the series, that sequence. So this is the limit as 1, as n goes to infinity of 1 plus 1 over n to the n. Now, in, I believe, chapter 1, they give you this formula that says that the limit as n goes to infinity of 1 plus x over n to the n is equal to e to the x for any x. Well, notice we've got x equals 1. So this is, in fact, just e. And e is not 0. It's bigger. So by the nth term test for divergence, we then know that the summation from n equals 1 to infinity of this sequence we looked at, so the series that's associated with the sequence, that diverges. Okay, so what the nth term test for divergence says is that if this series was to converge, then the sequence would go to 0. Since the sequence doesn't go to 0, I then know that the series does not converge. Okay? Now, the second one is the summation from n equals 1 to infinity of 1/2 times 1/2 to the n, right? 0.5 is just 1/2, okay? Now, we have, first of all, we should recognize that this is a geometric series. If you're confused, try writing out a few terms. So the first term, when n equals 1, this is going to be 1/4. When n equals 2, this is going to be 1/8, 1/16, and so on. Okay. Now notice, in getting between these two terms, we multiply by 1/2. In getting between these two terms, we multiply by 1/2. Every time we go from one term to the next, we multiply by 1/2. So then we know it's a geometric series. We have this constant ratio between terms. Okay. Now for geometric series, we know we have this formula that as n, the summation as n goes from 1 to infinity of ar to the n minus 1 is a over 1 minus r for r is less than 1, right? So this is what we have, and we'd like to use it, but notice here we've got n. We don't have n minus 1, we have just n. So we're going to need to rewrite some things and see what we can do with that. So there's a lot of ways to do this. I think probably the simplest way is to recognize that we can just factor one of these halves out of every term, right? So this is just a summation. We can write it like 1/2, or 1/4 plus 1/8 plus 1/16. Now we've already got a half, so really this, the way that they've written it is 1/2 times 1/2 plus 1/2 times 1 over 2 to the 2, right? And so on and so forth. What we'd like is for one of those, for the each of these to be 1 less power, okay? So I'm going to pull out this half, and so I'm going to have 1/4 times 1/2 to the 0, right? Just 1, plus 1/4 times 1/2 to the 1, and so on. And then I'll have that n minus 1 power. So in other words, I'm going to rewrite this as 1/2 times 1/2 times 1/2 to the I'm going to rewrite this, sorry. Okay, so I'm rewriting this as the summation from n equals 1 to infinity of 1/2, and then from each term I'm factoring out one of those halves, and then I'm left with 1/2 to the n minus 1. Okay, so now I've got the summation as n goes from 1 to infinity of 1/4 times 1/2 to the n minus 1. And now I can apply my formula. Now I have n running from 1 to infinity, and I have a power of n minus 1 up in top. Okay, so here my a is 1/4, my r is 1/2, and notice r is less than 1. So this is just 1/4 over 1 minus 1/2, which is 1/4 over 1/2, which is 2/4, or finally 1/2.